it got me thinking, what's going on in Dead Space in terms of science? What's up, you scholars of enlightenment? Dr. Sam Gregson, particle physicist here again. I hope you've had a fantastic week and have a brilliant weekend in store. A few weeks ago, the Dead Space remake was released. The original is one of my all-time favourite games. I mean, who doesn't love ripping undead space zombies limb from limb with an assortment of engineering tools? And this update does the original Dead Space phenomenal justice. I absolutely loved it.
Hey, that's pretty good.
However, as a particle physicist, I have a problem beyond the obvious. I couldn't help but notice the masses of particle physics littered throughout Dead Space. Plasma cutters that happily dismember people from across the room, particle-based contact beams that essentially allow you to carry the Large Hadron Collider around, and most notably, gravity manipulation devices like gravity tethers, telekinesis, and the force gun that allow you to literally bend the very fabric of space and time with impunity. Let's be honest, the engineering health and safety standards aboard the Ishimura are kind of in the toilet. However, it got me thinking, what's going on in Dead Space in terms of science? Is the type of gravity manipulation we see in Dead Space even possible? And what would it entail? So, if you're up for digging into the gravitational physics of an amazing game, and promise not to get more butthurt than a recently deceased member of the crew that Isaac has jovially stomped on, you piece of shit, let's get into this. If you're not up for that, this is your last chance to leave.
Turn it off. Hey, Isaac!
Isaac? Carver, what's going on?
Isaac!
Dead Space includes many examples of apparent gravity manipulation. Gravity tethers that can be used to crack planets and rip them apart. The telekinesis glove, a smaller version of the gravity tethers that Isaac can use to pull objects closer and then fire them away. The force gun that pushes objects away from Isaac, buying him a moment of respite. And even localized gravity systems that can be switched on and off as frequently and as quickly as Elon Musk posts terrible memes to Twitter.
I'm just going to keep stealing their memes and posting them without giving them any credit.
But how do we know that these devices are even based on the force of gravity? As far as scientists are aware, there are four main fundamental forces of nature. The strong force that binds together protons and neutrons inside the nuclei of atoms. The weak force, which is responsible for radioactive decay of nuclei. The electromagnetic force, which is responsible for electromagnetic forces, such as the forces between charges and magnets. And gravity, the force between masses. In Dead Space, devices like the telekinesis glove are capable of attracting both magnetic and non-magnetic materials from large distances, so the force they rely upon cannot be electromagnetically based. The force also cannot be based on the strong force or the weak force. The strong force is confined to very short distances, roughly the scale of the atomic nucleus. Otherwise, your phone would be pulling the nuclei in your eyes towards it right now, and we'd all be clumped together in one huge, overly friendly nucleus. The weak force also has a short range, as it's mediated by the massive W and Z bosons. The only force that can attract all forms of matter, all of which have mass, from a significant range, is gravity. Gravitational forces act over the grand distance scales of solar systems and galaxies. So given the fact that the devices shown in Dead Space can pull and push many different forms of matter, and given that they do so from significant distances, they must be examples of gravity manipulation devices. Indeed, if you dig around in the audio logs, text logs, and lore of Dead Space, and that of its follow-up Dead Space 2, this extensive use of gravity manipulation is confirmed. United Spacefaring Guild History Series, Titan Station, Conquering a Moon, Part 1 of 2. Planet cracking first became feasible in the decades following the discovery of the unified field theory, which allowed us to control the graviton in the same manner we were accustomed to controlling the electron. So Dead Space points to the fact that widespread gravity manipulation is possible in a future society that has developed a grand unified theory and can control gravitons. It seems that gravity manipulation devices in dead space rely on the production, manipulation, and control of beams of gravitons.
What the hell is even that?
So, what the hell is going on? And what in Altman's name is a graviton? Our current view of gravity, Einstein's general relativity, is classical in nature. It deals with large, macroscopic masses. In general relativity, planets, stars, or black holes distort and curve the space-time around them, and this curvature in turn controls how objects move in their vicinity, turning straight-line trajectories into curved orbits. However, there is another way of looking at fundamental forces, a framework that instead of looking at classical macroscopic objects, incorporates quantum mechanics, the physics of the very small. It's known as quantum field theory. The standard model of particle physics, one of the most accurate scientific theories ever devised, tells us that three of the fundamental forces of the universe, the strong, weak, and electromagnetic forces, can be explained by quantum field theory. In the quantum field theory picture, forces between particles, and hence objects made of particles, are a result of the exchange of so-called boson particles between particles that carry a charge related to the force in question. The electromagnetic force is due to the electromagnetic boson, the photon, coupling between particles that carry electrical charge. Gluons couple together particles that carry color charge, for example the up and down quarks in protons. The weak W and Z bosons couple particles that carry weak hypercharge or isospin. Quantum field theories have been phenomenally successful at explaining particle physics phenomena. The theory of quantum electrodynamics is one of the most rigorously tested theories of all time and can predict the anomalous magnetic moment of the electron to a precision of better than 1 part in a billion, all from first principles. Given the phenomenal success of these quantum field theories and the standard model of particle physics in explaining the forces and interactions we see in our universe, many believe that gravity must also be fundamentally quantum in nature, and hence mediated by an exchange boson, the graviton. This graviton would couple particles with gravitational charge, or put more simply, any particles or objects with mass, exactly as we see with gravity. So, electromagnetic forces can be thought of either as 1. Due to a charge creating a classical electromagnetic field around it, and that field creating forces on other charges that enter the field, or 2. Due to the exchange of photons between electrical charges. In a similar way, perhaps gravity can not only be thought of as the classical warping of space-time by masses, and then classical gravitational fields, but also as the exchange of gravitons between these masses. It's the aim of the field of quantum gravity and wider grand unified theories to put gravity into the same quantum field theory framework as the other three fundamental forces, and show that they are all an expression of one higher level phenomenon. Work is ongoing. However, at the moment, we're stuck with our classical view of gravity, Einstein's 100-year-old theory of general relativity. Efforts to unify quantum mechanics and general relativity have met with mathematical complications. The mathematical models created have been plagued with infinities and are said not to be renormalizable. In addition, the very existence of the graviton has not been experimentally confirmed. Gravity is incredibly weak compared to the other fundamental forces. So if the graviton does exist, the likelihood of an individual real graviton interacting with a matter-based detector is incredibly low. Previous estimates have suggested that a detector with the mass of Jupiter, orbiting an incredibly strong source of gravity like a neutron star, might observe a handful of graviton interactions per century. And some theorists have even suggested that conventional matter detectors capable of detecting gravitons would be so dense that they would collapse in on themselves into a black hole. So detecting gravitons by any conventional means is not likely to happen anytime soon. What's more, many have even questioned whether they exist at all. Perhaps the fact that gravity is so weak compared to the other fundamental forces indicates that it operates in a completely different way and cannot be explained in the quantum field theory framework. Perhaps it has no quantum component. Perhaps it's fundamentally different to the other three forces. Perhaps it is truly a classical force. So, if we don't even know gravitons exist, I guess we've hit a bit of a dead end, right?
Right? Wrong.
We're not giving up so easily. The fact that something might not exist never stopped any of the characters in Dead Space from blasting their plasma cutters at hallucinations. So why should we be any different? Dead Space says gravitons exist, and what's more, ChatGPT says they exist. So let's proceed under that assumption. So let's accept that gravitons exist, and gravity is fundamentally quantum in nature. Let's forge ahead.
Witness the conviction of a true believer!
But before we do that forging ahead, realize that that's the science of quantum gravity that is supposedly behind the gravity manipulation devices of Dead Space. We've covered a hell of a lot of ground, and I've done a lot of editing. So that's the end of part 1. In part 2, we will discuss whether manipulating quantum gravity in the ways depicted in Dead Space makes theoretical sense, and what we would need to learn and produce as a species to make the gravity manipulation devices of Dead Space a reality. I hope you return for part 2. I promise to make us whole. I want to know what you think, because you're the scholars of enlightenment that I do this for. So please take a moment, if you wish, to let me know down in the comment section. And if you like this video, please consider leaving a like, subscribing, setting up notifications, and sharing this video more widely. I can't tell you how much these simple actions help me out and how much I'd appreciate it. Thanks for watching. Thanks for being scientific. Thanks for being bad.